This is the Chapter 3 lecture on scientific measurement. We have already done half of the material in this chapter. So all of the information in the math and calculator worksheet like sig figs, scientific notation, rounding, the metric conversions, all of those things are part of Chapter 3. So in this lecture, I am only going to go over the new stuff that is not included in that worksheet. Now we're going to go over some terminology for measurements. First, we're going to talk about the difference between qualitative and quantitative measurement. So first, let's talk about qualitative. So qualitative, like qualities. So a qualitative measurement uses words to describe the measurement. For example, it's very big or it's very small. So see how words are being used to describe the size or the measurement of something. Quantitative measurement, like quantity, okay, you're actually going to be given a number, a numerical value for the measurement. So for example, the substance has a mass of 5.0 grams. So that is an example of a quantitative measurement because a numerical value was provided with the measurement. You also need to know the difference between accuracy and precision. So first I'm going to talk about accuracy. So accuracy is basically how close you get to the true value. So if we're doing a lab and you're expected to collect 10 grams of product, and if you get pretty close to that 10 grams, let's say you get 9.9 grams, then we could say that you are pretty accurate. Precision, I like to describe precision like how consistent you are. So typically in a lab we'll do 2 or 3 trials. So that means that we do the lab procedures like 3 times and collect data. And then we kind of compare all of those results. So if we do the lab or do 3 trials and all of the trials are pretty consistent, then we say that we were very precise, okay? And that's what precision is. Here is the equation for percent error. This is written correctly in your notes. Once again, sometimes when my slides get downloaded into this program, it makes things a little off. So that really is right there, okay? So yes, those are the absolute value signs, okay? Because you're never going to get a negative percentage. So this is an equation that you might use in a lab. You don't need to know this for the test or anything. So the experimental value minus the true value, okay, divided by the true value, that's, once again, the absolute of that, and then times 100, okay? And that will give you the percent error. So if you get a very high percentage of error, that means that maybe your lab technique wasn't very good, or there was contamination, or something went wrong in the lab, okay? So if you get a high percentage of error in a lab, you would have to explain what went wrong in the lab and why there was such a huge error. So usually if you're within like 20%, that's usually pretty good for a lab. Okay, so here's an example to emphasize the concept of accuracy and precision. So I'm assuming that many of you have played the game of darts before, or you understand the goal in the game of darts. So obviously in a game of darts, the goal is to get the darts into the bullseye, which is that middle part right there. So if we take a look at the top dartboard, you'll notice that the darts are kind of just all over the place, okay? So if the goal is to hit the bullseye, then we would say that this person is not accurate, okay? And then notice how every time they threw the darts, it was just kind of random, all over the place. So they are not consistent also. So we would say they are not precise, and therefore they're also not accurate. Now let's take a look at the middle one here. Okay, still did not hit the bullseye. So this person is not accurate. But if you look at the location of their darts, they're pretty consistent every time. So this person is precise. All right, so precise but not accurate. Let's take a look at the third one here. Hit the bullseye. So this person is accurate, consistent every time also. So not only accurate but also precise. Now we're going to talk about the International System of Units. We call these the SI units. So you do need to be familiar with the SI units throughout chemistry. So SI, they probably got that from the French term Système International, so that we call these the SI units. It's kind of like the standard set of units that everyone in the entire world should use. So for length, it's the meter. For mass, it's the kilogram. Volume is in liters. Temperature is in Kelvin, and we'll talk about temperature in a little bit. And when we get to chapter 7, we will talk about moles, okay? But make sure you are familiar with these SI units. Now we're going to talk about the difference between mass and weight. So I know when you hear those terms mass and weight, they sound like they mean the same thing, okay? But there is a difference, and this is the difference right here. The weight depends on gravity, okay? Weight depends on gravity and mass doesn't. So since your mass depends on gravity, that means that depending on your location, your weight could be different because the gravity is different. But no matter where you are, your mass will always remain the same. Okay, density. So density is a mass and volume relationship. Okay, it is a mass and volume relationship. So here is your equation for density, dmv. Okay, so D stands for density. Okay, D is density. M stands for mass. And V stands for volume. Okay, you do need to have this equation memorized. You will need this for the test. Okay, so density is mass over volume. So we will do some practice problems in class, plugging in the numbers and solving for the missing variable. So since it is a mass and volume relationship, some of the common units that you will see for density would be grams per milliliter. Okay, you have to have mass over volume, or you would see grams per cubic centimeters. Okay, a cubic centimeter is equal to 1 milliliter. All right, so 1 cubic centimeter is equal to 1 milliliter. They are equivalent to each other. So you do have to recognize that cubic centimeters is a volume unit, okay? Because you can get that by measuring length, width, and height, and that gives you volume. Now, the last thing that you need to know for this chapter, you basically need to know this right here, how to convert back and forth between Celsius and Kelvin. Those are the two main temperature scales that we use in chemistry, okay? So there should be a little degree sign here, and I believe it's written correctly on your notes. Once again, it got downloaded a little weird here. So 0 degrees Celsius plus 273 will give you Kelvin. So the symbol for Kelvin is a capital K, and there's no degree sign, okay? So for an example, let's see, if I give you 35 degrees Celsius, and I want you to convert that to Kelvin, okay? What would that be? So, in order to convert it to Kelvin, you would add 273. So let's add 273 to that. 5 plus 3 is 8, 7 plus 3 is 10, carry the 1. So then that would be 308 Kelvin. All right, now what if it was the opposite? What if I gave you Kelvin first? So let's say I give you 375 Kelvin, and I want you to convert that to degrees Celsius. Okay, so what do you think you're going to do to turn the Kelvin into Celsius? That's correct. You would subtract 273. So then let's subtract 273. So let's do our math. 5 minus 3 is 2, 0, 1. So then you get 102 degrees Celsius. Okay, so definitely make sure you have this memorized. You know how to convert your temperature back and forth between Celsius and Kelvin. You'll need that for the whole entire year of chemistry, and you will need to know that for the test. And one of the cool things about the Kelvin scale and why we like to use it in chemistry is because there are no negative numbers. 0 Kelvin is referred to as absolute 0, and that is the lowest possible temperature. So there are no negative numbers on the Kelvin scale.